Now, we are going to learn some of the tricks to remember some of the conversions. So for that, first I am drawing the figure. So like this you have to draw, and in the center I am writing 1. At one corner I am writing sine, cos. Here I will write cot, cosec, sec, and tan. Sine Sine and cosec I am opposite to each other. Cos and sec I am having opposite to each other. So cosec theta is equal to 1 upon sine theta. Same way sec and cosec are cos are there. So sec theta equal to 1 upon cos theta. Same way tan and cot are there. So cot theta equal to 1 upon tan theta. Now if I move like that, the arrow form to tan theta equal to sine theta upon cos theta. Sine theta will be equal to cos theta upon cot theta. Cos theta upon cos theta upon sine theta. So if I reverse it, so cos theta into sine theta upon cos theta. So cos theta got cancelled. Cos theta will be equal to cot theta upon cosec theta. If I clockwise I go, I will get one pattern of formula, that is cot theta will be equal to cosec theta upon sec theta. Is sec theta equal to tan theta upon sine theta. Now one doubt arises in my mind, if I instead of clockwise, if I start anti-clockwise, then so cot theta will be equal to cos theta upon sine theta. Both the ways you can move and you will get the correct formula. Here we can get the correct formulas also, that is sine square theta plus cos square theta equal to 1. Now I am drawing the hexagon again to show you how that sine square theta plus cos square theta is coming. So this is my hexagon which was shown there, and at the center it was written 1. So in the first triangle it was sine theta cos theta. So if I take that one triangle and I say sine square theta plus cos square theta will be 1. At the third vertex I am having 1, so that will be equal to 1. Then second triangle if I take, that was tan theta and sec theta. So tan square theta plus 1 equal to sec square theta. The third part was cosec and cot. So if I take that triangle, so 1 plus cot square theta equal to cosec square theta. All the three formulas I get from here. In an easy way I can remember them. Now exercise 8.3 question 1 says sin A, sec A and tan A in the terms of cot A. I have to find all these relations in term of cot A. So first sin A. So sin A means root of sine square a, root of sine square a. So now sine square I can write 1 upon cosec square, 1 upon cosec square a. So that root, because sine a equal to 1 upon cos a, cosec a. 1 upon cosec A. So now that I am again shifting as cosec square A, I am shifting as 1 upon 1 plus cot square A. Because just now we saw 1 plus cot square A equal to 1. That formula. Cot square A equal to cosec square A formula just now we saw. So that I am using here. So that will be 1 upon root of 1 plus cot square A. Then second one is sec A. Sec A. So that I can write as sec square A equal to 1 plus tan square A. So if I, so 1 plus tan square, instead of that I am writing 1 upon 1 plus cot square A. So that will be cot square A plus 1 upon cot square A. So if I do square root on both sides, so I will get sec A. So that will be root of cot square A plus 1 upon cot square A. So that will be root of cot square A plus 1 upon cot A. Third one is tan A. So tan A equal to 1 upon cot A, 1 upon cot A. So now second question says write all the other trigonometrical ratio of angle A in terms of sec A. So sine square A plus cos square A equal to 1. So sine square A will be 1 minus cos square A. So sine square A will be 1 minus 1 upon sec square A. So this will be equal to, because cos A equal to 1 upon sec A, that's why I have used this formula. Now that if I do LCM, so sec square A minus 1 upon sec square A. So sine A will be equal to root of sec square A minus 1 upon sec A. So I got sine in the form of sec. Now cos A will be 1 upon sec A. So directly I am getting that. Then tan A equal to sin A upon cos A. So in place of sin A, I can write the above one, that is root of sec square A minus 1 upon sec A whole upon 1 upon sec A. Sec A. So that will be equal to, if I reverse and multiply, so I will get sec square A minus 1 root whole upon sec A into sec A upon 1. So sec A got cancelled. So I got equal to root of sec square A minus 1. Now cosec A equal to 1 upon sin A. So sin A already we have found, so that value I can directly keep 1 upon root of sec square A minus 1 whole upon sec A. So that will be equal to sec A upon whole upon sec square A minus 1 whole in square root. Now cot A equal to 1 upon tan A. So tan A already we have found. So 1 upon root of sec square A minus 1. Now question 3 says choose the correct alternative. Justify your answer. 9 sec square A minus 9 tan square A equal to. So first I am taking 9 common from both. So that 9 into 1. So answer will be my 9. Because sec square A equal to minus tan square A equal to 1. So the answer is 9. So option B is right. Now second one says 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta equal to. So first I am converting everything in sine and cos. So 1 plus sine theta upon cos theta plus 1 upon cos theta into 1 plus cos theta upon sine theta minus 1 upon sine theta. Minus 1 upon sine theta. Now doing LCM. So LCM will be in the first bracket, it will be cos theta. So cos theta plus sin theta plus 1 in the numerator upon cos theta. Second bracket I am getting sin theta as denominator. So sin theta plus cos theta minus 1 whole upon sin theta. Now if I multiply that both, so see, if I consider sin theta plus cos theta as one unit, so cos theta plus sin theta whole square minus 1 whole square upon cos theta sin theta. So this will be equal to a square plus b square plus 2ab. So cos square theta plus sin square theta plus 2 sin theta cos theta minus 1 whole upon cos theta sin theta. But cos square theta plus sin square theta equal to 1. So I am putting that value there, 1 plus 2 sin theta cos theta minus 1 whole upon sin theta cos theta. So 1 and minus 1 got cancelled. So my final answer will be 2 sin theta cos theta upon sin theta cos theta. And numerator and denominator sin theta and cos theta will get cancelled. So final answer will be 2. Now next one is sec A plus tan A into 1 minus sin A. So first converting everything into sin cos. So 1 upon cos A plus sin A upon cos A into 1 minus sin A. So if I do LCM, so 1 plus sin A upon cos A into 1 minus sin A. So in the numerator I am having 1 plus sin A, 1 minus sin A. So that will be 1 minus sin square A whole upon cos A. Now I know that 1 minus sin square is cos A, cos square A. So cos square A upon cos A. So cos A got cancelled. So my answer will be cos A. Fourth one says 1 plus tan square A upon 1 plus cot square A. So 1 plus tan square A is sec square A and 1 plus cot square A is cosec square A. So now cosec square, sec square I can write 1 upon cos square A whole upon 1 upon sin square A. So if I reverse I will get 1 upon cos square A into sin square A upon 1. So that is sin square A upon cos square A. So that is tan square A. Now Question fourth is prove the following. Cosec theta minus cot theta whole square equal to 1 minus cos theta upon 1 plus cos. So LHS I am starting solving. So whole square it is. So first I will be opening the I will be converting it into sine and cos. So 1 upon sine theta minus cos theta upon sine theta whole square. So now sine theta will be LCM. So 1 minus cos theta whole upon sine theta whole square. So that will be 1 minus cos theta whole square whole upon sine square. Now if I open the bracket of 1 minus cos theta, so it will be 1 minus cos theta into 1 minus cos theta upon sine square theta. And sine square theta I am writing as 1 minus cos square theta. So 1 minus cos theta into 1 minus cos theta upon a square minus b square. So a minus b, a plus b I am writing. So 1 minus cos theta, 1 plus cos theta. So 1 minus cos theta, 1 minus cos theta got cancelled. So that is RHS. Now second one is cos A upon 1 plus sin A plus 1 plus sin A upon cos A equal to 2 sec A. So again LHS I am taking. So now I have written LHS. Now I am doing first LCM there. So 1 plus sin A into cos A. So cos square A plus 1 plus sin A whole square. So that will be cos square A plus 1 plus 2 sin A plus sin square A whole upon 1 plus sin A into cos A. Now sin square plus cos square is 1. So 1 plus 1 will be 2. 2 plus 2 sin A upon cos A into 1 plus sin A. So if I take 2 common in the numerator, 1 plus sin A whole upon cos A into 1 plus sin A. So 1 plus sin A, 1 plus sin A I am cutting. So I got 2 upon cos A. So 2 upon cos A means 2 sec A. So 2 sec A which is equal to RHS. Now third one says tan theta whole upon 1 minus cot theta plus cot theta upon 1 minus tan theta equal to 1 plus sec theta cosec theta. So again LHS I am converting it into sin cos. So tan theta means sin theta upon cos theta minus 1 upon cos theta whole upon sin theta plus cot theta will be cos theta upon sin theta whole upon 1 minus sin theta upon cos theta. Now doing LCM in the both the denominators. So I will get sin theta upon cos theta whole upon sin theta minus cos theta whole upon sin theta plus cos theta upon sin theta whole upon cos theta minus sin theta whole upon cos theta. Now multiplying with the reverse, so sin theta upon cos theta into sin theta upon sin theta minus cos theta plus cos theta upon sin theta into cos theta upon cos theta minus sin theta. So sin theta into sin theta will be sin square theta Now, if I multiply them, sin square theta upon cos theta into sin theta minus cos theta plus cos into cos will be cos square theta. So, now from here I am taking minus common so that I can write cos square theta upon sin theta into sin theta minus cos theta. So, now if I do, now I am again doing the LCM. So sin theta cos theta into sin theta minus cos theta. So I will get sin cube theta minus cos cube theta. So now using a cube minus b cube formula, sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta whole upon sin theta cos theta into sin theta minus cos theta. So sin theta minus cos theta got cancelled, the whole bracket. So sin square theta plus cos square theta will be 1. So 1 plus sin theta cos theta whole upon sin theta cos theta. So now if I write, if I make the denominator separate, so it will be sin theta cos theta upon sin theta cos theta plus 1 upon sin theta cos theta into 1 upon cos theta also I can write. So this got cancelled. So I got 1 plus cosec theta into sec theta. Now next is 1 plus sec a upon sec a equal to I have to prove. So LHS I am taking and solving it into sine and cos. So 1 plus 1 upon cos whole upon 1 upon cos. So LCM cos a plus 1 upon cos a into upon 1 upon cos a. So now multiplying with the inverse. So cos a plus 1 upon cos a into cos a upon 1. Into cos A by 1. So cos A got cancelled. So that is coming as cos A plus 1 or 1 plus cos A whole upon 1 into. Now I am multiplying with minus. So 1 minus cos A upon 1 minus cos A. So 1 plus cos A into 1 minus cos A whole upon 1 minus cos A. So see, denominator of RHS I got. Now this will be 1 square minus cos square A. So 1 minus cos square A upon 1 minus cos A. So 1 minus cos square will be sin square. So that will be equal to sin square A upon 1 minus cos A. So I got RHS. Now fifth one, again it is asked to prove that. So and I have to use the identity cosec square A equal to 1 plus cos square. So first I am taking LHS, so that is cos A minus sin A plus 1 whole upon cos A plus sin A minus 1. Now I am dividing both with sin A, numerator. So cos A upon sin A minus sin A upon sin A plus 1 upon sin A whole upon cos A upon sin A plus sin A upon sin A minus 1 upon sin A. So that will be equal to cos A minus 1 plus cosec A whole upon cot A plus 1 minus cosec A. That is equal to cot A plus cosec A minus 1. Now instead of minus 1, I am writing cosec square A minus cot square A. I have used the identity. Whole upon cot A minus cosec A plus 1. As it is, I am keeping. So that will be equal to now cot A plus cosec A in one bracket minus cot A or cosec A minus cot A into another bracket cosec A plus cot A whole upon cot A minus cosec A plus 1. So now from in the numerator I am taking cot A plus cosec A common. So in bracket I will have 1 minus cosec A. Minus into minus will be plus, so plus cot A whole upon cot A minus cosec A plus 1. Now if you see, the bracket is common, so I am cutting that. So I got cosec A, cot A plus cosec A. So that is equal to RHS. Now sixth one is root of 1 plus sin A upon 1 minus sin A equal to sec A plus tan A. So here I am multiplying LHS with conjugate. So LHS equal to 1 plus sin A upon 1 minus sin A. And multiplying with conjugate. So 1 plus sin A upon 1 minus sin A I am multiplying. 1 plus sin A upon 1 plus sin. So that will be root of 1 plus sin A whole square upon 1 minus sin square A. So that will be equal to whole root of 1 plus sin A whole square upon cos square. So that will be equal to, now if I remove the bracket, root, so I will get 1 plus sin A whole upon cos A. Now cos A I am splitting up. I am making the denominator below both of them. So 1 upon cos A plus sin A upon cos A. So 1 upon cos A will be sec A and sin A upon cos A will be tan A. So I got RHS. Now seventh one says sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta equal to tan theta. So LHS, I am taking sin theta from the numerator common. So 1 minus 2 sin square theta whole upon cos theta I am taking common. So I will get 2 cos square theta minus 1. So now sin theta into sin square theta plus cos square theta minus 2 sin square theta. I have used the formula a square plus b square minus 2ab. Cos theta into 2 cos square theta minus sin square theta plus minus cos square theta. Instead of 1, I have written sin square theta plus cos square theta. Now, moving ahead, sin square theta and 2 sin square theta. So that will be cos square theta minus sin square theta. Now, in the denominator also, cos theta into 2 cos square theta minus cos square theta will be cos square theta. So cos square theta minus sin square theta. So now cos square theta minus sin square theta will get cancelled. So that is equal to sin theta upon cos theta, which is equal to tan theta, which is equal to RHS. Now eighth one says sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. Now I have taken the LHS. Now first I am using the formula A plus B whole square. So sin square A plus 2 sin A cosec A plus cosec square A plus same way there also I am using the formula. So cos square A plus 2 cos A sec A plus sec square A. So now see, I got sin A and cosec A will get cancelled and cos A and sec A will get cancelled. So that I am cancelling. So 2 plus 2, that will be 4 plus sin square A plus cos square A will be 1. So that 1 I have written. Plus, now I am left with cos square A plus sec square A. So, this is equal to 5 plus 1 plus cot square A plus 1 plus tan square A. So that 5 plus 6 plus 7. So, 7 plus cot square A plus tan square A. And that I got RHS. Now ninth one says cosec A minus sin A into sec A minus cos A equal to 1 upon tan A plus cot A. So LHS I have taken. Now I am writing cosec A minus sin A. That sin A I am converting into cosec A. So 1 upon cosec A, sec A minus 1 upon sec A. So now doing LCM. So I will get cosec square A minus 1 upon cosec A into sec square A minus 1 upon sec A. So that will be equal to now cot square A upon cosec A into tan square A upon sec A. So now cot square A I am converting, cosec A I am converting to sin. So sin A upon cot I have converted to tan. So upon tan square A whole upon into tan square A into cos A. So tan square A got cancelled. So sin A into cos A. Now RHS I am taking and solving it because now I can't solve LHS. 1 upon tan A plus cot A. So that will be 1 upon sin A upon cos A plus cos A upon sin A. Now doing the LCM in the denominator. So 1 upon sin square A plus cos square A upon sin A cos A. So sin square A plus cos square A will be 1. So sin A cos A upon 1. So therefore it is equal to sin A cos A. Now both I have got as sin A cos A. So LHS equal to RHS. Now last 10th one is 1 plus tan square A upon 1 plus cot square A equal to 1 minus tan A upon 1 minus cot A whole square equal to tan square A. Now LHS I have taken. Now 1 plus tan square A will be sec square A upon cosec square A. So sec square means 1 upon cos square and cosec means 1 upon sin square. So that will be sin square A upon cos square A. So that is tan square A. So first one I proved it is equal to tan square A. Now let us prove the second one. 1 minus tan A upon 1 minus cot A whole square. So that will be equal to 1 minus sin A upon cos A whole upon 1 minus cos A upon sin A whole square. Now this I am making the denominators in numerator and denominator. So cos A minus sin A whole upon cos A whole upon 1 sin A minus cos A whole upon sin A whole square. So that will be equal to cos A minus sin A whole square upon cos A cos square A into sin square A upon sin A minus cos A whole square. So that will be equal to, see the whole square will get cancelled, cos A minus sin A minus cos A. So sin square A upon cos square A. The reason is because minus sin, so whole square if I do it, I will get plus only. So that is equal to tan square A.